Welcome to our channel. In this session, we will discuss recognition of tokens. What do you mean by token? How the tokens are generated? The first phase of compiler is lexical analyzer. That lexical analyzer reads a stream of characters. That means simply it reads the source program as input and produces sequence of tokens as the output. That means the tokens are generated by lexical analyzer. Now, what do you mean by this one? Token is any valid identifier, keyword, operator, some delimiters, some numbers. Everyone is called token. Now, generally, the tokens are specified by using regular expression. Tokens are specified by using regular expression, and the main important thing is the tokens are recognized by using transition diagrams. Tokens are represented by using transition diagram. Simply transition diagram in the sense a diagram which shows how to move from one state to another state by reading some input symbol. Okay, this is the recognition of tokens. Now, under this concept, we have different types of tokens and we will discuss each type of token with an example transition diagram. So, for this, consider the tokens are recognition of identifier. Identifier is one token. Recognition of some delimiter is another token. Recognition of some keywords. Recognition of some relational operators. And finally, recognition of some numbers. In this session, we will discuss these 5 of tokens, how these tokens are represented by using, that is recognized by using transition diagram. Step by step, we will move to each and every one. What do you mean by first one? Identifier. What is an identifier? Identifier is a name that is given to either a variable or array or a function or structure. Simply it follows some rules. What are the rules? Depending upon the language, the rules of the identifier is changed. Suppose in C language, an identifier contains either alphabets, that means the letters A to Z, digits 0 to 9, and a special symbol underscore. Coming to Pascal, only alphabets and digits are allowed. Special symbols are not allowed. That means depending upon the programming language, the rules of the identifier is changed. Now for this example, we will consider the Pascal language. Now what they contains? Letters and digits. And the most important thing is, always identifier begin with a letter only. A letter followed by any number of letters or digit. Suppose the regular expression is letter A, B and so on small z, A, B and so on capital Z. That means any of the letter is possible. Digit. So the possible digits are 0, 1, 2 and so on 9. This is the letter, this is the digit. What you required? You required the regular expression for identifier. Suppose ID is equal to, what is the rule? The first one is compulsory a letter followed by, you can write either 0 or many number of times letter or digit. Simply letter or digit. Whole star y, 0 or many occurrences. This is the regular expression. Now construct the transition diagram for this regular expression. Initially I am at state 0. Whenever we are receiving a letter in the sense the letter is replaced with any of this one. If you are replacing the letter, suppose move to state 1. Is state 1 is a final state? Yes. We have only letter A, it is accepted. I have only letter B, accepted. Letter in the sense, for example, int A. Here A is a variable, A is an identifier. Suppose AB. So one is compulsory followed by any number of letters. So self loop we are placing the letter, or A1, A2, this is also followed, comma digit. This is the transition diagram. If I am given any identifier to you, simply traverse the identifier from the start state, and whenever it reaches the final state, the identifier is the valid token. The identifier is valid token. This is the way to recognize an identifier. Okay, right? Next, I am erasing this one. What is the second type of keyword? We have different keywords. The second type of keyword is recognition of some delimiter. What do you mean by delimiter? Simply a blank space or a tab space or a new line space or simply a word space is called delimiter. Delimiter is, suppose int space a comma b. That means we are separating the data type with variable. That space is called delimiter. Whenever space occurred, that is also considered as a token. So simply the transition is what space tends to. We have delimiter, either one delimiter or followed by any number of delimiters. That means assume if the delimiter is one space. So a what space contains either single space or zero or many, whatever the number you are given, that many number of spaces occurred by using the star. Star specifies zero or many occurrences, but at least one is compulsory present. So in the similar way, the transition diagram is start from 0. If at least we are receiving one delimiter, move to final state 1. That is, the delimiter is recognized. After one delimiter, you have any number, that is completely depending on your wish. Suppose delimiter. Remember, whenever we are making the self loop, in the sense, 0 or many occurrences. 0 or many occurrences are recognized by using self loop. Okay. This is the recognition of delimiter. Suppose the next one is recognition of keywords. So keyword is also a token. So what are the different keywords coming to data types? Into, float, char, double. Those are the keywords. If, else, while, do, those are the keywords. For is a keyword. Go to statement, break, continue. All the words that are reserved for some fixed meaning are considered as a keyword. Suppose in C language we have 32 keywords. Writing the transition diagram for 32 keywords is very difficult. Suppose consider one simple example. If, while, for. Assume these are the three keywords. I am constructing transition diagram for these three keywords only. The simple procedure. Start at state 0. Whenever I occurred, what is your string? String in the sense, what is your token? If. Whenever I occurred, move to state 1 and then F occurred. That means this is accepted. So I, F both are occur, we are moving into final state. This is the way to recognize. Suppose W, H, I, L, E. You got it? Whenever the first letter is W, if all are followed in the same sense. Remember, each and every case we have other symbol also. If other symbol in the sense, suppose other than H, if any other symbol is present, that is considered as an invalid token. Only if you are moving from start state to final state, that is called valid token. Similarly for also, F, suppose state 8, O, state 9, or state 10. So I am given the state numbers in the sequential order for violating the ambiguity. So FOR. This is the way to recognize a token. Whatever the token they are given, you have to construct the transition diagram for this token. Suppose you have many number of keywords, it is not possible to write the transition for all the keywords. So this is the example. Now I am erasing this one. Now the fourth one is recognition of relational operator. Relational operator. What are the different relational operator? Less than or equal to, greater than or equal to, double equal to, not equal to. These are the different relational operators. Suppose see the diagram, start at state 0 if we are receiving a symbol less than. If you are receiving a symbol less than, move to state 1. Now at state 1 we have two possible cases. Assume this is my string a less than b. This is one type of string. A less than or equal to b. This is another type of string. That means after less than you have equal to is one choice, other than equal to is another choice. So I am using two directions. One is equal to, so less than or equal to case. Another one is you have any other symbol in the sense either B, C, D, whatever it is, other symbol, we are moving into state 3. That is A less than B. A less than or equal to B. This is one thing. Similarly, for greater than also, again we have two choices. 3 is equal to 4. This is the case of greater than or equal to. Suppose after greater than, other than equal to, suppose the same case. After greater than, other than equal to, we are moving into some other state. Here you have to write other symbol. Other symbol in the sense, other than is equal to, remaining are called other symbols. Sorry, this is assume state 5. Now any other remaining, double equal to, you have to write like this. One is equal to state 6, another equal to state 7. This is the recognition of double equal to, not equal to state 8, equal to state 9. This is the way to recognize the tokens. And remember one more thing, whenever a token occurs, a token is represented in a pair format. How it is pair format? Simply the name of the token followed by the attribute value. For example, see this one, less than or equal to. Here are a relational operator, less than or equal to, assume the name is LE. That is the attribute value is LE. This is the way to represent. For example, relational operator only less than, LT in the sense less than. Suppose relational operator GE greater than or equal to, for state 5 relational operator greater than only. So for state 7 relational operator EQ, that is double equal to. Finally state 9 relational operator NE not equal to. That means each and everything is represented by using token representation. This is the recognition of relational operator. Now we are moving into the most important thing of tokens. That is, this is the most important thing, and at the same time compared to remaining 4, this is somewhat confusing. Okay, see this one, recognition of numbers. What are the different types of numbers? Generally we have integer number, floating number. How do you represent the number? For example, consider different examples. Some 253. This is an integer number. This is one type of representation. Suppose 253.12. This is a floating point number. Now 253 exponent 10. This is E represents exponent, that is 253 into e power 10. That is exponential notation. 253 point some 1 to e10. So before e, here we have an integer. Before e, we have some floating point number. Along with e plus 10, e minus 10. E, that is after exponent, we have three cases: without any symbol, with plus, with minus. The before one is you can write either integer this one or this one. Observe, we have many variations. For this, you have to construct that first regular expression. It is, if you understand carefully, it is very simple. A number, everything is considered as a digit. First, I am representing an integer number. So this is a digit. You can have any number of digits. You don't know length of the number. So write like this: digit plus. What do you mean by plus? One or more occurrences is called plus. So the digit is repeated one time or many number of times. Digit is repeated one time or many number of times. Okay, this is the number 2 digit plus, followed by next to this one. Here, remember, actually we don't know whether it is a floating point or floating point number or not. Dot digit plus. What is mean by this one? This is compulsory. Followed by, if it is a floating point number, only one dot is present. Followed by here this one. You have any number of digits. Now, followed by question mark. So, question mark in the regular expression, question mark is a meta character which specify 0 or 1 occurrence. Plus specifies 1 or more occurrence. Star specify 0 or more occurrence. Question mark specify 0 or 1 occurrence. What is mean by this one? This entire thing is repeated either 0 times or 1 time. For example, if it is repeated 0 times, in the sense it does not exist, only this one is existed. So this is an integer number. Suppose if it is existed 1 time, 253.12. You got it? This is integer. So this is for adding of the float number, followed by what is the thing? Exponent. In the exponent, so if you are using this bracket, that means these are the optional, plus minus. That means after the exponent, you have either plus symbol or minus symbol. Again, either 0 occurrence or 1 occurrence. Either 0 occurrence of the plus or 1 occurrence of the plus. 0 occurrence of the minus, 1 occurrence of the minus. So, suppose E is completed. Suppose whether plus or minus, whatever it is. If question mark replaces with 0, this is valid. Question mark replaces with plus, this is. Question mark replaces with minus, this is. You got it? Now, after this, you have again any number of digits. Digit plus. Got it? Now, for each and everything, is exponent is compulsory. For this number, exponent is not a compulsory number. You got it? Observe carefully. This is for integer. If you want to add floating number, this is for float. If you want to exponent, this is E. If you want to add any symbol or not, this one. And finally, after exponent, this is. Here, this entire thing is also either 0 or 1 occur. If you want to include exponent, we can write. If you doesn't want to include exponent, you can simply ignore this one. Now, the same thing is represented in transition diagram. Initially, start at state 0. Whenever we are receiving a digit, move to state 1. At state 1, we have 1 or more occurrences of digits. So, compulsory 1 digit must and should be present, followed by any number of digits. After that, dot is the operator. Now, digit plus in the sense, whenever dot occurred, compulsory after dot at least 1 digit must and should present. Suppose 253 point dot, it is not valid. 253 point dot, at least 1 number. Suppose state 2. So like this, compulsory at least 1 digit, followed by any number of digits. First, my assumption is if it completely present, I will write down the transition. So question mark replaces with 1 occurrence. Suppose after 3, we have exponent. After exponent, what are the 2 symbols? Either plus or minus. Move to state 5. Plus or minus, move to state 5. Now, this one digit state 6 digit. Okay, this is the skeleton, just to basic skeleton. So digit plus is represented by using this one, dot digit plus is represented by using this one, e plus minus digit and digit. Now in all the cases I consider one occurrence. For example, after 6, if you have any other symbol other than digit, if you have any other symbol, suppose move to some other state, other symbol move to some any other state, and if it is accepted means this is simply accepted. For example, after this one position, if this is not existed, this is your example, if this is your example, after digit you can directly move to state 4 with e only, that is 253 e plus or minus, 253 e plus or minus, that is one thing. For example, other symbol other than exponent, simply this is closed. If I have other symbol, simply this is closed. So if exponent is present or exponent is not present. Similarly, after this one, to represent only this one without exponent, if you have any other symbol, simply 9. Now observe, this is the way to recognize the tokens. This is the way to recognize the token. For example, after E, again one more thing, plus and minus are optional. So, if there is no plus and minus, by using digit only you can move this one. Analyze this transition diagram carefully. These are the 5 different ways, that is 5 different types of tokens. How do you recognize the tokens? By using these transition diagrams. Thank you.